use of American wire gauge 8 wire in a 3/4-inch electrical metallic tubing conduit is not permitted. According to the National Electrical Code Table 373.6. A. The maximum conductor size for 3/4-inch electrical metallic tubing conduit is American wire gauge 6. Installation of a bare equipment grounding conductor in electrical metallic tubing conduit is not permitted. According to Section 250.118, equipment grounding conductors must be insulated. The use of 12-foot of flexible liquid-tight conduit is permitted provided it is listed for the purpose, as specified in Section 350.30 of the National Electrical Code. Removing the grounding and neutral bar from the main service panel is not permitted. Grounding and neutral bars must be installed and bonded together, as required by Section 250.24 of the National Electrical Code. The practice of having one neutral and grounding bar in a house subpanel is not permitted. Subpanels must have separate grounding and neutral bars, adhering to Section 250.32 of the National Electrical Code. Running a conduit with 4 brown ungrounded conductors and 1 neutral conductor is not permitted. All ungrounded conductors must be marked for identification, in accordance with Section 200.6 of the National Electrical Code. Concerns regarding these installations raise serious safety issues. Firstly, American wire gauge 8 wire in a 3/4-inch electrical metallic tubing conduit violates Section 373.6. Secondly, a bare equipment grounding conductor in electrical metallic tubing conduit violates Section 250.118. Thirdly, the use of flexible liquid-tight conduit must comply with Section 350.30. Fourthly, the removal of the grounding and neutral bar from the main service panel violates Section 250.24. Fifthly, having one neutral grounding bar in a subpanel violates Section 250.32. Sixthly, ungrounded conductors must be marked for identification, complying with Section 200.6. These installations are not in compliance with the National Electrical Code and pose significant safety risks. It is recommended to report these concerns to the appropriate authorities, such as the local electrical inspector. When examining electrical installations, several specific code requirements must be followed to ensure safety and compliance. Firstly, conductor sizing within conduits is crucial. The National Electrical Code specifies the maximum allowable conductor size for different conduit types and sizes. For example, using American wire gauge 8 wire in a 3/4-inch electrical metallic tubing conduit is a violation because the code mandates a maximum of American wire gauge 6 for the conduit size, referencing Table 373.6. Secondly, grounding and bonding practices are vital for safety. Equipment grounding conductors, which provide a path for fault current, must be insulated to prevent unintentional contact and ensure effective grounding. Installing a bare equipment grounding conductor in electrical metallic tubing conduit is a direct violation of Section 250.118, which requires insulation. Thirdly, flexible conduit usage has specific requirements. While flexible liquid-tight conduit can be useful in certain applications, it must be listed for the intended purpose. This means the conduit must meet specific standards for its construction and intended use, as outlined in Section 350.30. Fourthly, the configuration of main service panels must adhere to strict grounding and neutral requirements. The grounding and neutral bars in the main service panel must be properly installed and bonded together. Removing these bars violates Section 250.24. Which ensures that the grounding and neutral systems are correctly connected to provide a safe electrical path. Fifthly, subpanels must have separate grounding and neutral systems. Combining the neutral and grounding bars in a subpanel creates a hazardous situation by allowing neutral current to flow through the grounding system. This violates Section 250.32, which requires distinct grounding and neutral terminations in subpanels. Sixthly, conductor identification is essential for safety and proper circuit function. All ungrounded conductors must be clearly marked to indicate their purpose, such as phase identification. Using unmarked conductors, like 4 brown and grounded wires with a single neutral, violates Section 200.6, which ensures that conductors are easily identifiable for maintenance and troubleshooting. These violations highlight the importance of adhering to the National Electrical Code to prevent electrical hazards and ensure the safety of electrical systems. When dealing with electrical installations, understanding conductor sizing, grounding practices, flexible conduit use, and proper panel configurations is essential. Conductor sizing in conduits is a critical aspect of electrical installations governed by the National Electrical Code. The code specifies the maximum allowable conductor size based on the type and size of the conduit to prevent overheating and ensure safe operation. For instance, if American wire gauge 8 wire is installed in a 3/4 inch electrical metallic tubing conduit, it violates Table 373.6. A, which dictates that the maximum conductor size for that conduit is American wire gauge 6. This regulation is in place to ensure that the conduit can effectively dissipate heat generated by the conductors, preventing insulation damage and potential fire hazards. Grounding and bonding practices are fundamental to electrical safety, providing a low impedance path for fault currents to return to the source, thereby tripping over current protection devices. Equipment grounding conductors, crucial for this purpose, must be insulated according to Section 250.118 of the National Electrical Code. This insulation prevents unintentional contact with other metal parts, ensuring that the grounding system functions correctly in the event of a fault. Installing a bare equipment grounding conductor in electrical metallic tubing conduit is a violation because it compromises the integrity of the grounding system. Flexible conduit offers versatility in electrical installations, allowing for connections in tight spaces or where movement is necessary. However, the use of flexible conduit is governed by specific requirements in the National Electrical Code. Section 350.30 stipulates that flexible liquid-tight conduit must be listed for the intended purpose. This listing ensures that the conduit meets specific standards for its construction, flexibility, and resistance to environmental factors, guaranteeing its safe and reliable performance. Main service panels are the entry point for electrical power into a building, and their configuration is critical for safety and proper operation. The grounding and neutral bars in the main service panel must be properly installed and bonded together, as required by Section 250.24. This bonding ensures that the neutral and grounding systems are interconnected, providing a common reference point for voltage and facilitating the flow of fault current. Removing these bars disrupts the grounding system, creating a hazardous situation. Subpanels, which distribute power to different areas within a building, must have separate grounding and neutral systems, as mandated by Section 250.32 of the National Electrical Code. This separation prevents neutral current from flowing through the grounding system, which can cause nuisance tripping of overcurrent protection devices and increase the risk of electrical shock. Combining the neutral and grounding bars in a subpole creates a path for stray currents, compromising the safety of the electrical system. Conductor identification is essential for maintaining and troubleshooting electrical circuits. All ungrounded conductors must be clearly marked to indicate their phase or function as required by Section 200.6 of the National Electrical Code. This marking allows electricians to easily identify the correct conductors during maintenance and repairs, reducing the risk of errors and ensuring the safe operation of the electrical system. Using unmarked conductors, such as 4 brown and grounded wires with a single neutral, violates this requirement and increases the potential for confusion and mistakes. Adhering to these code requirements is paramount for ensuring the safety and reliability of electrical installations. Ignoring these regulations can lead to serious consequences, including electrical shocks, fires, and equipment damage. Proper installation and maintenance practices, along with regular inspections, are essential for maintaining a safe electrical environment. Let's further elaborate on these key areas. The National Electrical Code provides detailed guidelines on conductor sizing within conduits, ensuring that conductors operate within their safe ampacity limits. This is to prevent overheating, which can lead to insulation breakdown and potential fire hazards. Table 310.15. B16 in the National Electrical Code is commonly used to determine the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. However, deterring factors must be applied when multiple conductors are bundled together in a conduit, as outlined in section 310.15. D1. For example, if more than 3 current-carrying conductors are installed in a conduit, the allowable ampacity of each conductor must be reduced to account for the increased heat generated by the group. This deterring is crucial for ensuring that the conductors do not exceed their maximum operating temperature. Grounding and bonding are essential for creating a safe electrical system by providing a low impedance path for fault currents. The equipment grounding conductor plays a critical role in this process, connecting non-current carrying metal parts of equipment to the grounding system. According to section 250.118 of the National Electrical Code, equipment grounding conductors must be insulated to prevent unintentional contact with other metal surfaces. This insulation ensures that the grounding system functions properly in the event of a fault, providing a reliable path for fault current to flow back to the source. Flexible conduit is often used in electrical installations to provide flexibility and protection for conductors in challenging environments. However, the National Electrical Code sets specific requirements for the use of flexible conduit depending on the type of conduit and the application. Section 350.30 specifies that flexible liquid-tight conduit must be listed for the intended purpose. This listing ensures that the conduit meets specific standards for its construction, flexibility, and resistance to environmental factors, guaranteeing its safe and reliable performance. Additionally, the length of flexible conduit runs is often limited to prevent excessive voltage drop and ensure effective grounding. Main service panels serve as the central distribution point for electrical power in a building, and their configuration is critical for safety and proper operation. The grounding and neutral bars in the main service panel must be properly installed and bonded together, as required by section 250.24 of the National Electrical Code. This bonding ensures that the neutral and grounding systems are interconnected, providing a common reference point for voltage and facilitating the flow of fault current. The grounding electrode system, which connects the grounding system to the earth, must also be properly installed and maintained to provide a low impedance path for fault currents. Subpanels are used to distribute power to different areas within a building, and they must have separate grounding and neutral systems, as mandated by section 250.32 of the National Electrical Code. This separation prevents neutral current from flowing through the grounding system, which can cause nuisance tripping of overcurrent protection devices and increase the risk of electrical shock. The grounding and neutral conductors must be properly sized and connected to their respective terminals in the subpole, ensuring a safe and reliable electrical system. Conductor identification is essential for maintaining and troubleshooting electrical circuits, and the National Electrical Code provides specific requirements for marking conductors. Section 200.6 specifies that all ungrounded conductors must be clearly marked to indicate their phase or function. This marking allows electricians to easily identify the correct conductors during maintenance and repairs, reducing the risk of errors and ensuring the safe operation of the electrical system. Color coding is commonly used to identify conductors, with black, red, and blue typically used for the phases in a 3-phase system, and white or gray used for the neutral conductor. Proper installation and maintenance practices, along with regular inspections, are essential for maintaining a safe electrical environment. Electrical systems should be inspected regularly by qualified professionals to identify potential hazards and ensure compliance with the National Electrical Code. Any deficiencies or violations should be promptly corrected to prevent electrical shocks, fires, and equipment damage. By adhering to these code requirements and best practices, electrical systems can be designed, installed, and maintained to provide a safe and reliable source of power. To delve deeper, let's consider some examples and scenarios. Imagine a scenario where American wire gauge 10 conductors are installed in a half-inch electrical metallic tubing conduit to supply power to a lighting circuit. According to table 373.6. In the National Electrical Code, the maximum conductor size for a half-inch electrical metallic tubing conduit is American wire gauge 8. This installation violates the code and could lead to overheating of the conductors, potentially causing a fire. To correct this violation, the conductors should be replaced with American wire gauge 8 or smaller conductors, or the conduit size should be increased to 3/4 inch to accommodate the American wire gauge 10 conductors. In another scenario, consider a situation where a homeowner replaces a damaged receptacle in their bathroom. They neglect to connect the grounding conductor to the grounding terminal on the receptacle, leaving the metal parts of the receptacle ungrounded. This violates Section 250.114 of the National Electrical Code, which requires all metal parts of electrical equipment in wet locations to be grounded. This lack of grounding could create a shock hazard if a fault occurs, potentially endangering the homeowner. To correct this violation, the homeowner should connect the grounding conductor to the grounding terminal on the receptacle, ensuring that all metal parts are properly grounded. Consider a situation where a contractor installs flexible metal conduit to connect a motor to a junction box. They fail to use proper fittings to secure the conduit to the junction box, leaving the conduit unsupported and vulnerable to damage. This violates Section 348.30 of the National Electrical Code, which requires flexible metal conduit to be securely fastened and supported. This improper installation could lead to the conduit becoming disconnected, exposing the conductors and creating a shock hazard. To correct this violation, the contractor should install proper fittings to secure the conduit to the junction box, ensuring that it is properly supported and protected. In a commercial building, a maintenance worker discovers that the grounding electrode conductor connecting the grounding system to the earth is corroded and damaged. This violates Section 250.64 of the National Electrical Code, which requires the grounding electrode conductor to be protected from physical damage. This corrosion could compromise the effectiveness of the grounding system, reducing its ability to safely conduct fault currents. To correct this violation, the maintenance worker should replace the damaged grounding electrode conductor with a new conductor that is properly protected from corrosion. In a manufacturing plant, an electrician installs a subpanel to supply power to a new piece of equipment. They fail to separate the neutral and grounding conductors in the subpanel, connecting both to the same terminal bar. This violates Section 250.32 of the National Electrical Code, which requires separate neutral and grounding conductors in subpanels. This improper installation could cause neutral current to flow through the grounding system, creating a shock hazard. To correct this violation, the electrician should separate the neutral and grounding conductors, connecting them to separate terminal bars in the subpanel. These examples illustrate the importance of adhering to the National Electrical Code and best practices when installing and maintaining electrical systems. By following these guidelines, electricians and homeowners can ensure the safety and reliability of their electrical systems, protecting themselves and others from electrical hazards. Now let's explore more specific aspects of electrical installations and the code requirements that govern them. Conductors in raceways are subject to specific fill requirements to ensure adequate heat dissipation and prevent damage to the insulation. The National Electrical Code specifies the maximum number of conductors allowed in a raceway based on the size and type of raceway, as well as the size and type of conductors. Table 1 in Chapter 9 of the National Electrical Code provides detailed information on raceway fill requirements, taking into account the cross-sectional area of the conductors and the raceway. Exceeding the maximum allowable fill can lead to overheating and insulation breakdown, potentially causing a fire. Grounding electrode systems are critical for providing a low impedance path for fault currents to return to the source, ensuring the rapid operation of overcurrent protection devices. The National Electrical Code specifies the requirements for grounding electrode systems in Section 250, including the types of electrodes that are permitted, the size of the grounding electrode conductor, and the methods for connecting the electrodes to the grounding system. Common grounding electrodes include metal underground water pipes, ground rods, and concrete encased electrodes. The grounding electrode system must be properly installed and maintained to provide a reliable path for fault currents. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. The National Electrical Code specifies the requirements for overcurrent protection devices in Section 240, including the types of devices that are permitted, the ampacity rating of the devices, and the methods for installing the devices. Overcurrent protection devices must be properly selected and installed to protect the electrical system from damage and prevent electrical hazards. Wiring methods refer to the various ways in which conductors are installed and protected in electrical systems. The National Electrical Code specifies the requirements for wiring methods in Chapter 3, including the types of wiring methods that are permitted, the methods for supporting and securing the wiring, and the methods for protecting the wiring from physical damage. Common wiring methods include electrical metallic tubing conduit, flexible metal conduit, and non-metallic sheath cable. The wiring method must be appropriate for the environment and the application to ensure the safety and reliability of the electrical system. Equipment labeling and listing are essential for ensuring that electrical equipment meets safety standards and is suitable for its intended use. The National Electrical Code requires that electrical equipment be labeled and listed by a recognized testing laboratory, such as Underwriters Laboratories or Canadian Standards Association. The label indicates that the equipment has been tested and meets applicable safety standards. The listing indicates the intended use of the equipment and any limitations or restrictions on its use. Equipment must be properly labeled and listed to ensure that it is safe and suitable for the application. By adhering to these code requirements and best practices, electrical systems can be designed, installed, and maintained to provide a safe and reliable source of power. Regular inspections and maintenance are essential for identifying potential hazards and ensuring compliance with the National Electrical Code. Remember, when working with electrical systems, always prioritize safety and consult with qualified professionals to ensure that the work is performed correctly and in accordance with applicable codes and regulations.